Hello everyone, and thank you for having me. My name is Aashi. I am an entrepreneur, a part-time Kaggle practitioner, and a freelancer. Apart from that, I am also the organizer for TensorFlow User Group Chandigarh. And today, I am honored to be a part of TensorFlow User Group Mysuru and taking part in sharing my knowledge of Kaggle with you all. Today, we'll be going through a lot of things in Kaggle about how to get started, up from beginners to intermediates, and what it takes to get into Kaggle EDA, that is Exploratory Data Analysis. If you're someone who is looking to get started into EDA or you're thinking of getting started with Kaggle, I believe that EDA is the simplest for all the beginners to get started with. So before we get started with actual notebooks, we'll go through a bit about Kaggle, get you familiarized with the Kaggle homepage, what all Kaggle offers you, and then we'll dive into Kaggle EDA, which is really fun data set that is actually my favorite as well. So without any further ado, let's dive into Kaggle. I'll just take a second and take me off the screen a bit, and now we are ready to just go. Yeah. So, welcome to the world of Kaggle. Kaggle used to be a place for competitions and data sets, but now it provides a lot many things to all of you. So if you are a beginner, intermediate level, or a professional who uses ML and ML related stuff or techniques on your daily basis, Kaggle is something you can look forward to. So you can have some competitions like over here. So you might be someone who wants to practice their skills in data science or maybe ML and AI, then Kaggle is the thing for you. You have plenty of competitions to work with. You can form teams, you can work with best of people from around the world in Kaggle. Then we have plenty of data sets to work with. So you might have different tastes. You might have some interest in working with images dataset. So you can just go on and say computer vision dataset. You might even have some interest in, say, NLP. You might want to go and analyze the sentiments of, say, tweets on Twitter, or maybe some Facebook comments that you found were really annoying and you would like to make a detector that would detect those kinds of comments. So Kaggle datasets really help you to get through all those datasets for your projects that you might not find anywhere else. And of course, they are open source, but you always want to acknowledge the hard work of people who have done some scraping online and gathered that data set for yourself. Then we have some code over here. So if you're someone who is really new and don't really understand how to get started with Kaggle, Kaggle code is really important and useful as well. So what you can do is you can scroll around and see different notebooks made by people and contributions. So you can check out their codes. They are usually well documented. They are number of codes with snippets, and there are lots of codes with comments in them, and usually people are very helpful. If you drop a comment there that you didn't understand such and such lines, they'll be really helpful to turn up and just tell you and explain you a bit more. Apart from that, there are some discussions forums as well. So discussions here are not only linked to journal discussions like getting started and all, but there are some specific questions as well. So you might have some product feedback, or you might have some particular question that has been bugging you on some project you'll be working on. So you can take part in these forums and you can get answers from all around the world. Apart from that, if you are a newbie or you are looking to enhance your technology skills and you really want to learn something new, so you can just go ahead and take these courses. Kaggle provides a lot of courses in that. You can go for SQL, you can go for computer vision skills, you can go for AI ethics, you can go for geospatial analysis, and lot more of that. So here, I'm not actually marketing Kaggle for you, but just giving you a tidbits of what you can use Kaggle for and how it can be helpful for your journey in your career. Now, going back to the topic for today. Today we are going to explore some data, and for you all I have selected a very special data, that is SpaceX launches of Falcon 9 and Falcon Heavy rockets. So this data is typically very interesting because for all of you who look up the sky and think what's beyond it, and at the same point there is a lot of things you can explore in this data set as well. But before we dive into the notebook itself, I just want to make sure that we go through a data that is provided by the person himself. So whenever you want to go through a data set in Kaggle, you'll usually find it in the forms of these columns, if it's a CSV data, of course. Now, these data are actually kept in form of columns and they do have a description. Though they do not have it here, but they usually do have some about the file details that you can use and find helpful when analyzing the data set. So here we have the flight numbers of the flight, we have the date of launch, the time of launch, which version or booster was used for the launch, then launch site, which launch site was used, what was the payload like, what was actually the mass of the payload, which orbit did you put the rocket in. So there are, like we know, there are lots and lots of orbits up there. So we might be interested in knowing that if the rocket went somewhere, in which orbit it was. And then if SpaceX is putting so much of money in these heavy launches and rockets, who is the actual customer? Right? What is it actually doing as a provider? What does it provide and who are its main customers? So it's just 10 of columns out of whole 12 columns, and you can see we have a variety. Like we have some numbers data, we have some orbits like Leo Geo, we have some strings here in the customer as well, we have some strings here, and then we have some time series data, we have some date data, and we have some flight numbers, we have integers data. So we have a variety of data to deal with over here. And when you have a little bit glance at the data, it really helps you to make up those questions in mind that actually help you a lot while doing the EDA. So in this, we can also go ahead and have a compact view. So just remove the above details. Then we have the column view where you can go ahead and look at each and every column that is provided and have a look if any of the data is, say, valid, mismatched, missing, what is the mean, standard deviation of that particular column. So it's provided for all the columns, almost all the columns, right? So as you can see, for payload, we have 165 unique values, right? Amazing, right? So without any further ado, let's just dive into the notebook itself. Here is it. So when you are actually into the environment of Kaggle notebooks, you have a screen like this. So you have some files, tab here, edit, view, run. If you're really familiar with Jupyter notebooks, it's much like that only. There is not much of difference. So you can make some versioning over here, while if you save your project once you're done, you can do some versioning, say version 1, version 2, and then you can pin the topmost version that you find was had the utmost results for you. Then you can run all the kernels at the same time, all cells at the same time. You can cut, copy, paste some cells. You can have some markdown cells and some code cells as well. You have some factory reset over here, as well as you can start and stop session at the same time. So before I tell you more about this, let me just start the session. So while we are explaining, we can get started with the session only. You can see over here is the data. So it is actually loading, it's preparing to load the data over here. So it says input. We have this whole data set of SpaceX launches, Falcon 9 and Falcon Heavy, right? We have the data. We can just use this copy file path to use the to get the path of the data we're going to be using. Then we have our output. Our output would be saved here in the working directory. We have some settings as well. So say you have a large data set and you would like to use some accelerator. So Kaggle also provides you some GPUs and TPUs for your working with the large data set. Apart from that, you can change your language. I'm using Python currently. You can change the environment. You can add some tags so that people can easily get to you to your notebooks, and then you can schedule a notebook run as well, right? So enough of the general talks here. Let's just dive into the code right now. Cool. So data everywhere. So we all know that data is everywhere. And what we want to do as a data scientist or maybe a data analyst is that we want to get some information out of that data. So we really have a lot of data. We have if you see around yourself, there is a lot of data. There might be a table, chair, fan, plants, curtains, whatever, right? There'll be a lot of things around you, but they're just data until and unless they provide you some information, right? Whenever you need them, they are the information. Otherwise, they're just data. They're lying around, right? So what is EDA actually? Why do we say exploratory data analysis? What we actually want from the data? So exploratory data analysis refers to the critical process of performing initial investigations on the data, so as to discover some patterns, to spot anomalies, to test hypotheses, to check assumptions with the help of summary statistics and graphical representations. So remember, what does it happen when, say, somebody, you don't know what is a pizza, say, right? So pizza has just launched and you have no clue how the pizza looks like. So think about it, that there's a person who is just telling you that pizza is a round figure having some sauces on top and lots of veggies, and say, yeah, that's a pizza. And then there is a person who actually shows you an actual image of a pizza on their phone. So what would you say? Which of the two will give you a better understanding? A person who's just saying some words, that is just data coming in, or someone who's actually giving you a visualization of that thing? I feel that visualization would be a much better path. So that only is EDA. What we are doing is we are exploring the data to get some initial investigation going on, to get some information out of the data provided to us. And EDA is not much of a really difficult or typical task to do. What we do usually in EDA is that we import the data set. Of course, you can collect your own data set. You can get some data set like I got from Kaggle or some other sources as well. There are a lot of ongoing sources that you can find on Google. Just Google some data set that you might need regarding some project and you will find that. Then there is understanding of the big picture. So what does the data set has to say on like a big scale? So like I was saying, we will go on and look for some investigative things. So the big picture here is, when I told you that we'll be working with SpaceX Falcon 9 and Falcon Heavy data set, so there's already a big picture painted for you that the data set will have something related to like rockets, say their time of launch, landing, all those kinds of things come into mind if you didn't have that glance of data before, right? Then we need to prepare the data so that we can work with it, and it is usually called data cleaning as well. Then you want to understand and explore some data, that is exploration. Then you want to study the relationship of various variables that are provided to you in the data set. And finally, you want to plot the data to infer some results. And in the last conclusion, we just conclude the whole thing that we got out of that data set into a report kind of thing, right? So let's just dive into this data set first. About this data set. So we know that Space Exploration Technologies Corporated, or short form is SpaceX, is an American aerospace manufacturer of space transportation services. And Falcon 9 is their rocket that can carry cargo and humans to Earth orbits, even reaching the International Space Station. So it gives you a thing that first, when we were thinking earlier about payloads, we can say that okay, Falcon 9 carries some cargo to and humans to say space, to orbit of the Earth, and also to International Space Station. We got the hint, right? Then it is produced by American aerospace company SpaceX. Technically, it is a partially reusable medium lift launch vehicle. So it is reusable here. So we can say that the rockets we'll be talking about, we'll be also talking about their landing, not only their launch, because they're usable. So they'll be landing, of course. Then we have Falcon Heavy rockets that are Falcon Heavy, that is a partially reusable heavy lift launch vehicle that is produced by SpaceX, an American aerospace manufacturer, right? So about this files, we have already covered these files, so we won't be going through this. And finally, dive deep into some code right now, right? So let's get started with this. So first up first is our imports. Let me just run this as well. So I am a colorful person and I love to add some colors that really help to explain the EDA much better. So what I did here is I chose my own color palette, and it's really easy. A bit of a small code snippet and that will do your work, right? So what we're going to do is we have three imports over here. So my first import is a matplotlib, that is a library that helps you with plotting all those bar charts, those scatter plots, and all those things. You can use matplot for those. Then we have Seaborn as SNS. So Seaborn is also a library much like matplotlib that helps you to plot the data. Then we have Plotly, that is also the kind of same thing. Because in EDA, most of the things we'll be doing is just plotting the data set. So what we'll be use is all the tools and all the imports that can be helpful to actually plot the data. So Matplotlib, Seaborn, and Plotly are all used in that sense only. So here is my small snippet for custom colors. So if you want to just go ahead and try it on yourself, just go ahead and try. Then it's the environment check. So I usually use this, and actually this is also a thing that I learned from Kaggle only, that you can use warnings so that you can ignore all those crazy red warnings that come up in your Jupyter notebook whenever you're working with it, and actually they do look really bad, so you can actually remove them, so all the warnings won't come here. Then yeah, this is the main thing over here. So this whole cell that you're seeing over here is this whole cell is actually the thing that Kaggle already provides you with. So this whole cell will already come as it is whenever you click on a new notebook and you create a new notebook. So Kaggle provides you few libraries that are already installed in Kaggle. So those are like NumPy and Pandas, that if you work with, you would know that are linear algebra libraries, as well as some data processing libraries. Because we'll be working with data, so we need some libraries to work around with data, and also we need some data processing, so we need Pandas for that. Then it gives you it prints out the file and directory name over here, right? So whenever I just run this code, the cell, and I'll have the file here. the CSV, the path of the CSV file that I'll be using, right? So once this is done and I have the data set in my hand, what I want to do is I want to just go ahead and use that data set, right? I just want to go ahead and try what's the data about and all, just try and find out more information about it. So let me just create a DF, just me read the CSV file. For that we use pandas. We use pandas.read CSV to read the file, read CSV file, and I just, in quotes, I've given the path of the CSV file that I found earlier in the here, right? Once that is done, I just want to go ahead and describe my data set. So what describe function does it already takes all those columns that has some numeric value in them, and it gives you the count, the mean of that whole column, the standard deviation, the minimum value, the maximum value, and some percentages value. Then we have df.info. So info function is really helpful. What it does is it gives you the data type first. So data type is very important because there are many times when you're actually working with the data and you see that, okay, it's an integer, but sometimes it's turned out that it is an integer, but it is a string. So it is in quotes, say it's like 555 in quotes, so it's a string, right? So sometimes you might find that the thing you were thinking is an integer turns out to be a string. So that's why it's really important that you use this info function to actually think about all the data types that you already have. And also it gives you the number of entries, that is 165, and if the count is null or non-null. So how many numbers or how many entries are null and non-null, right? Then let's just go ahead and get the head of that data. So we have already seen this data set before. Booster, landing, launch outcome, other two columns that we did not see before, but here they are, right? Then we have df.columns. So df.column is really helpful to just get those names of those columns, because sometimes you really miss out at some commas, some spaces, and you run your code and it says that this column does not exist. So it's really important that you use df.columns so that you can print out all the names of those columns. Then we'll be going to clean some data. So first thing first we have done is we understood the data. Then is we explored the data a bit. We got the big picture about the data. Now the third thing is we want to clean that data. So let's go and do that. So first we are going to check for null values, if any null value exists. So yes, we got a null value in time column. It says true, right? So what I'm going to do is I'm just gonna use nan. So wherever I'm going to use this replace function. So wherever a nan exists, I'm going to replace it with a numpy nan and say true. So what will happen is every place where there is a nan, it will be replaced by np.nan. And what it will do is in the next line, I can use drop na and x is equal 0 and in place equals 2. So in place here does is it makes it permanent, right? So drop.na, when I run this and then I find if there is any null value existent, so it says false, right? Next is I want to drop some columns. So let me just go ahead and take you back to head. So this was our head and we see that unnamed 0 is just a column. It's actually of no use to us because we already have a sequence number over here. We don't need this column. It does not provide any additional information that be of our use, right? So I just want to go ahead and just drop it. So like before, I'm just going to use this drop function, and you can use multiple columns if you want to drop multiple columns. You just need to put a comma over here, and just add the names of those columns that you want to drop, and then say in place equals to true. So it will just drop this function like forever, only while you're running this session, right? And now when we run df.head, that unnamed 0 is replaced. There is no unnamed 0, it has been dropped. Now, to my most favorite place is the questions. So, whenever I do a EDA, I make sure that I have a glance at the data. I have cleaned the data bit that I feel like, and then I ask few questions to myself. So, these questions are basically that whatever things that come into my mind whenever I see the data. So, say which launch site was used the most, which orbit was had the most launches. So whether SpaceX put some was taking some people in the rockets, were they going to the LEO orbit or the GEO orbit or maybe some other orbits, right? Who are the major customers? So maybe SpaceX works with NASA, maybe it works with ISRO. Why not, right? Then, what were the rate of launch outcomes? Which month saw the most launches? So, all these questions arise in your mind once you have a glance at that data. So, what I recommend you all to do is just go back at df.head over there and have a look at it and think about the question that come into your mind. Look at the orbit column and think about the question that comes in your mind, like which orbit is used the most, why this orbit only. You can almost search the Google for that if the data does not have the answer. But yeah, why Leo orbit or which orbit, right? So all these questions come into your mind. And then say we have launch outcomes. So we see a lot more successful here and partial failure. So we can find out if SpaceX is really successful with their Falcon 9 rockets or not, right? So we can conclude a lot more things by just looking at the data, because our mind is what actually finds out some patterns, but we cannot go through each and every data set. There are lots and huge data sets. We can go through each of those data sets and find patterns. That's why we want EDA, right? So let's just go ahead and to our first question. So my first question was, which launch site is used the most? So this is an image that I found online, and there are lots and lots of these black dots you can see. These are all of the launch sites that SpaceX usually use. So there is one Cape Canaveral in Miami, near Miami in Florida. Then there is one in Dallas, one in New Orleans, and also we have the launch direction. So what's the code about? This code is really simple. So if you are really a beginner and you just know a bit of Python, you'll be easily be able to do this. So launch site equals df, this is the column name, launch site dot value counts. So when I print this, what I get is it's a descending order of all the value counts of the launch site. So which launch site had the maximum values, was used most, had maximum counts. Like, so this KSC, this launch site, was used 47 times. In this data set, it was like, what we say, it was mentioned 47 times. That is, it was used 47 times for launches, right? Same with Cape Canaveral. Cape Canaveral is an Air Force base and it was used 19 times. And some even have some coded. Of course, they won't let us know about them, but yeah, they're coded. So what? We can still have some relation out of them. And let's just plot this figure. And here, I am just using that matplotlib plt dot figure. The size of the figure is 15,8. Then this launch site was the reference earlier. And finally dot plot, kind was a bar plot that I want to have. And my color is the colors for my color palette. And also use plt.show always. So it helps you remove those excess warnings and tidbits of data that shows up. So here we can see that the maximum time this KSCLC, this launch site was used. It's actually interactive and gives you a much more better understanding rather than just looking at the code, right? So most of the launches are classified, of course, so we don't really have a name. But above plot shows that the launch site of KSC LC39A is used the most. while fewer locations of US Cape Canaveral base are also used as an optimal base for launch, right? So my next question was, which orbit has most launches? Which orbit was used for most launches? Was it LEO, say this one, near to the Earth? Was it MEO, a bit far away from the Earth? Or GEO, a much more far away from the Earth? So when I run this code, so orbit, it's just the same thing that we did earlier, right? So we got LEO 63 times, GTO 36 times, and LEO ISS, that is International Space Station, revolving there 33 times. So we can say that that SpaceX rockets did make it to ISS. Let's just plot it. I am using a bar plot. This H means horizontal, just changing the shift. So we can see here that LEO orbit has been used the most. So most rockets were launched in LEO, low Earth orbit. Also, Starlink satellites orbit at 500 to 2000 kilometers from Earth to offer faster communications and often provide higher bandwidth per user than geo satellites do, right? So you can actually just Google these things and understand if you really have interest in these. But yeah, most rockets made it to LEO is still some information that is really meaningful, right? Then we have who are the major customers. The same thing I've done. No, complex use of code over here. Just the same snippets I'm using for different things, and we have different plots as well, right? See over here, we have NASA, we have SpaceX. So SpaceX works as a private individual for itself, and it also works with NASA and Iridium Communications. So all these are his customers. And yeah, here is a really interesting thing that I feel you all will like is word cloud. So word cloud is actually a library that is used to print out all those important things that have high frequency in that particular data set. So right now we were working with the columns, the customers columns, right? So we were printing who are the most customers of SpaceX. So what if that we don't plot these bar plots like this, rather we plot a word cloud like this. So you see all those big names over there, SpaceX, NASA CRS, then we have some Iridium Communications over in the base, a perfect JSAT and all. So what happens when we use word cloud is that it highlights or it gives the names that have more data to it more preference, or those names that have more importance, it gives them a bold big names rather than the ones those do not have much of more importance in that particular data set. So it's also one way to represent it, and usually it is used for such like string data sets only. So wherever there is a column that has strings and you feel like this word cloud would fit much better into it, go ahead and use it, right? So next is, what were the rates of launch outcomes? So what I did here was, here is outcomes of the launches. So if it was successful, if it was a failure, if it was a partial failure. So I just plotted a pie chart for that. And why it is useful is that it shows us very clearly that about 98.8% times SpaceX was really successful, right? And only 0.6% it was failure or partially failure, right? So let me just show you a bit about this code. It's just same things, but we have used it in bit of different way. What I did is I have these explode column over here. So what I did over here is that all those things that you see out here, these particular tidbits of data that I took out to just represent them differently, those are represented by explode. That is basically exploding those pixels outside. So 0.2 is for partial failure, so I just took it out a bit, and 0.5 is for failure. So it gives you a much better representation over there, right? Then you can also use something like this. So I gave you something like Plotly in the starting. That Plotly is really helpful, so I'm using Plotly over here, and you can use graph objects as Go. So graph objects is basically another library along with Plotly that you can use. It's basically different libraries that help you visualize better. So if you don't really want to go into much of those libraries, just don't. A simple representation would also give you a really, a really simplistic yet great visualizations, right? So this is also the same thing, like success rate is 98.8%. Then you can have this one, failure 0.6%, and this is like partial failure of 0.6%, right? Now let me just go ahead and see what was the maximum payload, mass payload like. So it was, see, some of here are classified. Some of here are 1500 and 15600. So maximum payload was around 25, 25 times 15,600 kgs of payload was sent to space. So over here, see, right? So most of the times it is also classified, and I have just put out like first 30 plots over here only, because I did not have much space. I just used the first 30 ones that I could get, right? So from the above bar graph, it is evident that a payload of 15,600 kg seems most optimum, while the maximum payload limit seems to be 16,250 kgs, right? Next, question number 6 was, which month saw most launches? This is a really fun animation. I just want you to have a look at it. Cool. Right. So most launches, see the value count. It's just 1, 1, 1, 2. It does not give you much of information. So like it was October 8th, 2 times the launch took place on October 8th, and 1 time on 4th June, 1 time of 8th January, 1 time on 20th January. So we just look at it and we find that there is really no comparison of that. Like there is no particular date that they would set for for the launch. And what happens with the time? Same thing is with time. See, we have 111 and 2233, the value counts, right? No really not really a relation between, right? So it's kind of common sense as well, that there is no specific time and date for launches. It usually depends on the weather forecast, the wind direction, say if there is some technical fault or not. All these things are really dependent on for the launches rather than a particular date and time, right? So did booster made a successful landing? I hope they did. Let me just go ahead and share that with you. So see, isn't that a beautiful visualization, right? So we say that 53.7% there was a success, landing on the drone ship. About 11.7% successful landing on a ground pad, and about 8% successful on the ocean and all, right? And same you can do with this. So here I'm used group by, df.group by. It is basically used to group all those 2 or 3 columns together if you want to have like kind of, you want to find a relationship, or you think that those 2 datasets are really compatible with each other and you can find some relation to each other. So you can use group by function over here. So I've used booster landing and the booster version to depict all these, whether it was controlled success, it was a failure, it was a partial failure, what kind of success did we get from that, right? So it's really a colorful representation over there. So it's evident from the above pie chart that about 76.5% of the booster landing was successful, whether it was on the drone ship, on a ground pad, or in control landing in the ocean, right? Yeah, so that's the end for this Kaggle notebook. So if you really loved this, do share it with us. If you have any questions related to Kaggle, or getting started with Kaggle, or getting started with Kaggle EDA, do share it with us and we would love to answer them for you. Thank you so much for having me. Thank you.